So if you're joining us, warm-up number 9, make sure you copy that data. It's about 12 sets of data. And this is concerning scores on a pop parquet of a 10-point pop parquet. Hint, hint, wink, wink, tomorrow is Friday. Ha, ha, ha. From the corner. So, once we got that data, we said that we organize it in ascending order, starting from the lowest to the highest. Then we find the mean. And I go to the next screen, which is this one. We already did the work. And the mean was 92 divided by 12. And Serena said that it's approximately 7.6. All right. So then we take the 7.6. We're going to subtract from each of the numbers. And I'm going to go to the right in red. So 4 minus 7.6 is negative 3.6. 5 minus 7.6 is negative 2.6. 6 minus 7.6 is negative 1.6. 7 minus 7.6 is negative 0.6. Write that twice. 8 minus 7.6 is 0.4. Is that correct? We write that twice. 9 minus 7.6 is 1.4, 3 times. And 10 minus 7.6 is 2.4, 2 times. And what do we need to do again? We need to, again, find another mean, but for, oh, no, my bad. Am I skipping a step? Yeah, what am I skipping step? Tell your neighbor. And then Brianna's going to enlighten us. What did I skip? Brianna, what do I need to do? Yeah, square each of these numbers. And so on and so forth. So calculators, do your calculating. So, negative 3.6 squared. What'd you get for negative 3.6 squared, Drew? Negative times a negative is a positive, so this would be 12 point what? 12.96, write that in there. Negative 2.6 squared. Sean, what'd you get? 6.76, write that in there. Negative 1.6 squared, what'd you get for that, Mr. Q? All right, 2.56. Man, let's go. Negative 0.6 is squared, that's 0.36. Yes? 0.36 twice. 0.4 squared is 0.16 twice. Oh, sorry. 0.16. So far, so good, yes? 1.4 squared, that should be 1.96. Yes? Let's go. 3 times. And 2.4 squared, what'd you get for 2.4 squared, Georgia? .76 twice. Now we find the mean again for this. And do me a favor, I'm going to introduce another symbol. Look up. Write that. This is the Greek letter sigma, which is the letter S, which is the symbol that we use for the sum. We're going to first add all the numbers. Find me the sum first of all these numbers. What is the sum? Plug that into your calculators. 12.96 plus 6.76 plus 2.56 plus 0.36, 0.36, 0.16, 0.16, 1.96, 1.96, 1.96, 5.76, 5.76. What is the sum so far? Who's got it? What is it? 40.72. Let's see, 12, 20, 30, 30. Yeah, looks about right. All right, and then we divide that by 12 again to find our new mean, also known as standard deviation squared. Our standard deviation squared. So what is 40.72 divided by 12? Tell your neighbor, please. 40.72 divided by 12. Ethan, Reese, what'd you get? 40.72 divided by 12. Approximately 3.3. I'll take that. However, we don't need that. We need what? Standard deviation. Which means, how do we get rid of this squared? Remind your neighbor, please. Yeah, so take the square root of 3.3. What is that? Priscilla, what'd you get? Okay, what is square root of 3.3? On your calculator? $1.8. Hands, if you got 1.8, looks about right. So this is our standard deviation. All right. And that was last night's home plays, right? Well, right on cue. Bam. Go to Canvas, turn in your home plate, please. So our agenda for today, warm-up number 9, dot plots and standard deviation. We already know what dot plots are. That's the piece of cake, yes, triple plan or, tres leches, whatever. But standard deviation is becoming something in itself, yes? I didn't give you the whole thing yesterday because I didn't want you here. This is whelm over here, yes? So today we're going to add a little bit more to it. However, tonight's home play is 2 problems again. I'm going to give you the Nearpod code. Well, here's the Nearpod code. KQD2F. Make sure you go to that so you can get your home play there. Write that down, please. KQD2F. All right. So I'm going to pause the music. Is it recording? Yes. So here it goes. Do me a favor. Get your cell phones out. All right. On your cell phone, I want you to go to Canvas. Oh, yes. Or your Chromebook, whichever. Canvas. Go to my class. Go to grades. Look at your overall grade. Take a screenshot. And make sure you edit that at home, but get it signed before you save it by your parents. Bring that back tomorrow. Yes? No, I still haven't input the syllabus. That's why it says missing on there. That's fine. Don't worry about that. But I do want to make sure that your parents see the home plays. Okay? So, yeah. Get that signed. That counts as an assignment, and it's due tomorrow. Yes? Bring that back tomorrow. All right. With that said, previous home play, you already turned that in. There it is. Tonight's home play is this one. It's 2 problems, but don't copy that. You have the Nearpod code. You can get that later. So with that said, get a Cornell note ready. You don't need a Fourier model today. Our objective for today, I can represent data on dot plots and compute the standard deviation. I can represent data on dot plots and compute the standard deviation. I can represent data on the dot plots and compute standard deviation. And as I said, we already covered dot plots yesterday. Everybody's like, oh, piece of cake, Q. Yes. Computing standard deviation is what gives us problems. See what it did there? Problems. Yes. You guys remember Count Dracula from Sesame Street? Some of you? Yeah? 2. Ha, ha, ha. No? Never mind. He was one of my favorite characters. Yeah? 3. Ha, 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 ha. All right. So, we're still focusing on standard deviation. So yesterday, I gave you guys a Fourier model for dot plots. We know what they are. We did one of these, yes? Ice cream truck. And then you guys copied the Apodaca problem where the cafeteria and such, yes? All right. So, we got to some steps, and you didn't copy those because that's what we've been doing. However, we got to this one. So today, we're going to extend standard deviation. So copy the graph. Copy that, please. All right. You're like, what is that, Mr. Q? Well, students, bell curve. And this is what we called a normal bell curve. All right, here we go. So, normal bell curve. Oh, sorry. So the normal bell curve, you're going to be hearing more about that, especially once you graduate from here and you head to college. There's some professors that use that, and you've probably heard this before when you hear they're grading on the curve. You're like, oh, I think I've heard it in movies, yes, but once you get to college, it's going to make more sense because instead of saying, okay, guys, you need to score at least 90% to get an A. You see what I'm saying? Instead of doing that, they grade by the curve, which means they take the mean or the average of the class, they go 1 standard or 2 standard deviations up, and they say that's going to be the A. Let's say that the most they need to score is 88%. That's going to be the A to reach. You're like, oh, yeah. So that's why it is called grading on the curve. And a lot of people would be like, please grade on the curve. A lot of people were waiting for that because it was a rigorous course, and they were expecting that from the professor instead of trying to reach that 90 or 95%. So how does that work? So do this with me. Follow along. Down, straight down the middle. Draw a line straight down so you can split it symmetrically down the middle. Like so. Now, if you notice, it splits it in half. We have a half to the left, a half to the right. Now, mine's not completely, let's see. Is that better? Yeah? All right. So, what is that middle, Mr. Q? That's what we call the standard, or in other words, label this. Tell your neighbor what that is. Yeah, the mean. The mean is going to be the standard. So for example, I'm going to be nice, and I'm going to say that all of you are very dedicated to your studies. And I'm assuming that after you leave campus, you invest 3 hours a day for all your studies, and I'm talking about all your academics, 3 hours daily, times 5 days, that's 15 hours. So the mean or the average, we're going to label that 15 hours. 15 hours of study per week. However, after doing some computation, Mr. Q found out that the standard deviation, or what separates us either one way or the other from the 15 hours, is 3 hours. You're like, what do you mean, Mr. Q? Yeah, that some of you, if we go one standard deviation up, so if the average is 15 hours, but you are above, how many hours have you invested in study? 18 hours. That is correct. However, some of you, instead of going upward, you went the other way. And I understand, because some of you maybe have extracurricular stuff, and you are at negative standard deviation, which is the opposite direction. So instead of 15 hours, where are you at? 12 hours, because instead of 15 minus 3, you are at 12. You're like, oh, I see how it's working, Mr. Q. Yes. Now check this out. This part is what we call the norm or the normal setting for teachers to look at. We just see that, okay, the average is 15, so anything like 3 hours above that or 3 hours below, all that is the normal. You know, that's normal to us. We see, well, I understand 3 hours less or 3 hours more. That's understandable. However, the red flags for teachers start here when people go another standard deviation, -2 standard deviations below. So if the mean is 15, one standard deviation is 12. What is the other? Here it goes again. We started at 15. This is 12, and this is 9 hours a week. So that means divide that by 5. It's only 1 point something. That means you're only investing 1.75%. I mean 75 hours for your study. That means that you're investing out of 5 classes, only about 15 minutes per class for study. Ooh. That's not good. And that's a week. However, check this out, a positive red flag, if we go 2 standard deviations up, the mean was 15, 18 is 1 standard deviation, so that means this person is at what? 21 hours. That means they're investing at least 4 point some hours a day of study. Ooh. So that means they do their sports or their extracurricular, they get home like around 7. They maybe go do a part-time job till 9, and then 4 hours, so they go to bed like around 12 at night or 1. And do it again the next day. All right. Now, so far so good, yes? However, there's a major red flag for teachers when we go a 3rd standard deviation below. So we went from the mean being 15 hours, then 1 standard deviation below is 12 hours, another standard deviation is 9 hours, so now where are we at the 3rd standard deviation? 6 hours, that is correct. So that means 5 days divided by 6, that's only 1.2. So that's about an hour a day divided by 5, that's only 10 minutes per class that you're studying. Ooh, that's tough. However, the positive red flag is a positive third standard deviation. And this person is at what now? How many hours? 24 hours. That's a lot of studying, right? Now, I can tell you my wife was probably in that category. She's like a super nerd, you know? Like I was taking advanced senior courses, and when I saw her walk in, this beautiful young lady, her hair was flowing backwards with the wind, light shone in, and I was like, what? And she was a junior taking senior advanced courses. I was like, what? What are you doing here? Anyways, so she was here. She invested a lot of time in study. Now, does everybody see how standard deviations work? We're in the standard, which was 15 hours, but one deviation over, which is norm, one over, one below, but anything after that is above average or above norm. Now, let me give you some percentages. So, inside of the bell curve, we have percentages that we need to account for. So in here, we're going to put this right here is 34.1, and the one to the right, it is also 34.1. So the normal percentage, or the students that are going to score within that, those hours of study is going to be how much percent? 68.2 of the students fall within that range. If we go one standard deviation over, this is 13.6. This is 13.6. Another standard deviation over, this is 2.1, 2.1. Now, mind you, this is a curve, and this is an area under the curve, so all these are percentages. So let me add all of them. 34.1, 34.1, 13.6, 13.6, 2.1, 2.1. Let's add this. 1 plus 1 plus 1 plus 1, that's 4 plus 6, that's 10 plus 6, that's 16. Carry 1. 8, 9, 10, 11, 12, 15, 19. Carry 1. 3, 6, 7, 8, and 1 is 9. How much percent is that total up to right there? 99.6. Which means how much are we missing? We're missing, Mr. Q, 0.4. That means, look up, shade in here, this little itty bitty piece right here and here. Each of those are 0.2%. 0.2%, because it's 0.4 divided by 2. What does that mean? That there's some rare people that are here. Very rare, which means people that study more than 24 hours. Very rare. Or in basketball terms, there's people that are investing so much time into practice that they become like this person that is way out there. Michael Jordan. Michael Jordan used to get to each game 3 hours before to practice. He played in the game, which was a full hour. He stayed after the game to practice another 3 hours, and then he went home. And, of course, his teammates, they just went in and warmed up, played, and they went home. But he was a rare person. Kobe Bryant, another one. I went to Las Vegas to see a game between the U.S. and, I think, Puerto Rico. And I was waiting at this college auditorium. I got there early. I was very near the court, and I was just sitting there because I was at least an hour and a half early. And that's me, guys. I'm very I'm very time sensitive, if you want to call it. So I got there an hour and a half early, and I said I'll just eat lunch, get a nice seat. So I was there, eating some snacks, and all of a sudden I hear a basketball dribbling, and I was like, oh snap, somebody's coming out. Guess who it was? Kobe Bryant. An hour and a half before the game, he came out. He started doing drills, warming up, shooting the ball. full hour and a half. He played the entire game, and guess what? He stayed afterwards to do some more. Rare people, they fall into this category. So, whenever it is you guys are getting a career in your life, whatever that may be, make sure you invest time and polish your skill, because that's going to bring you above the average. What's the norm? 1 standard deviation, right? Between those. Anything after that above, you got to make sure you separate yourself so that you get yourself known for putting in work, whatever it may be. Does that make sense? Yeah? All right. From 1 to 5, how comfortable are you with a bell curve? Okay. So you're like, okay. So now check this out. What did we need to build our curve? We needed our mean. What else did we need? Standard deviation. You're like, oh, where are we going, Mr. Q? Well, we're going to this one. Copy this. Example super Q. Ha, 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 ha. You don't have to copy the entire problem or the verbiage. Just copy the data. And I'll elaborate on the problem in a little bit. So the data is 8, 8, 8, 7, 6, 7, 6, 7.5, 6.5, 7, 6, 0. Copy that data. Stay focused, please. All right. So here goes the context. Does everybody know what context is? Yeah, the focus of the whole thing. It says Mr. Q statistics class pop parte scores. So these are actual scores of a group parte that I gave to my statistics class. Let's see. How many groups were they? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 groups of 2 or 3. Doable. But check this out. Look at these scores. Out of 10 points. So, I mean, someone wasn't doing their home play or something. Yeah, the 0.2%. So, with that said, I want you to get help from your neighbor. I'm going to give you a head start. Tell your neighbor what to do with that data, please. All right, so get started, please. I'll give you a head start. I'm going to get a code for Nearpod so you can show me work in a little bit. Copy and go. Record that. What did you do first, Emilio? Yeah, you said organize them from the lowest to the highest. Very good. So therefore, start at 0. And then 6. 3 of them. Then 6.5. Then 7. 3 of them. Then 7.5. Then 8. 3 of them. And how many different groups were there? 12, is that correct? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. So we need to find the sum and then divide by 12 to give us the first mean. What is 0 plus 6 plus 6 plus 6 plus 6.5 plus 7, 7, 7, 7.5, 8, 8, and 8? Natalie. 77? All right, so let's write that in there. So to find the mean, we take 77 and divide by 12. 77 divided by 12. Share with your neighbor, see what they got. All right, what'd you get, Bernard, for the mean? 6.41, so our approximately is 6.41. Hands if you got something like that. All right, so we're going to take this mean, and we're going to subtract from each of these numbers. Minus 6.41, 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 minus 6.41. All right, so the first one, I'll do that one, negative 6.41. Yeah? Damn. The second one, what is negative 0.41? Yes? 3 times? All right, so we got that 3 times. 1, 2, 3. Let's go to 6.5 minus 6.41. That gives us 0.09. 0.09. Next, 7 minus 6.41 is 0.59. How many of them? 3. 0.59, 0.59. Next, 7.5 minus 6.41, that is 1.09. 1.09. Very good. Yeah, 7.5 minus 6.41 is 1.09. Next, 8 minus 6.41. 1.59. Looks about right. 3 times, 1.59 and 1.59. Tell your neighbor what to do next with those numbers. What do we do next with those numbers? Yeah, you square each one of them. Square them. There it is. Squared, 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 and squared. Calculators. All right. So 6.41 squared. And notice that I excluded the negative because negative squared is a positive, yes? All right. So 6.1 squared. Brianna, what'd you get? 6.41 squared. .08. Write that down, 41.08. Next, 0.41 squared. What'd you get for 0.41 squared? Gabriel. 0.16. Okay, I'll take that. 3 of those. 0.16. 0.16. All right. Next, 0.09 squared. Calculators, 0.09 squared. 0.0081. Thank you, Alec. 0.59 squared. Giselle, 0.59 squared. We need 3 of those. 0.35, 0.35, 0.35. 1 point, what? Are we going too fast or what? Because I'm going with the rhythm of the music. I'm like, let's go. Yeah? 1.09 squared. Janae, what'd you get? 1.19. 1.19. And 1.59 squared. What'd you get? Elias, 1.59 squared. We need 3 of those. 2.53. All right, 2.53. 2.53. Whew. All right. Tell your neighbor what to do with all these numbers now. Yeah, again, we need to know a new mean, yes? What is that called? Our new mean is going to be our Standard deviation squared, yes? All right. So add those up. Somebody give me the sum first. Let me write the big sigma. I need the sum first. $51.0481. It's rounded to 51.05. Yes? Let's see. 41, 40, 398. Okay, I see a couple of them. All right. Jeremy, they overruled you. 51.38. Yes? 39. Okay, not bad. All right. So, what do we do with this? Hold on. This is our standard deviation squared, 51.39. But that's not what we need. We need what? Standard deviation. How do we cancel this squared? Square root. So take the square root of 51.39. Square root of 51.39. What is it? Is it 7.17? If you round it, that's fine. Yeah? All right. So what was our mean? 6.41. What is our standard deviation? 7.17. So underneath that, let's draw our bell curve. Nice and neat like mine. Went kind of weird here. Hold on. There it is. And I'm going to split it right at the center. What do I label this line? Tell your neighbor. 6.41. 6.41. Which is our what? Our mean. There it is. So if I go one standard deviation up, what would be the score? 6.41 plus what? Did we get it right? Yeah, right? 7.17. Okay. $7.17 plus 6.41, so that's $13.58. And one standard deviation below. So 7.71 minus 6.4, that's negative 1.7. What was it? 7 point what? 17. So that is 80. No. 76. 76. 0.76. 0.76. All right. So I want you to highlight this right here. This is the norm. The norm. I think we might have made a mistake on the computation, but we'll leave it like that for right now. So look up. We need to summarize what we saw. These are scores of a pop party for 12 groups. Look up. If I was to plot all those scores in here, are they all going to fall within the norm? Look at the scores. Yes. Which is the one that's going to be close to the red flag? Everyone? 0. If I was to grade on the curve, that means that the average, this should be like a B, a 6. However, if I was going to grade just in points, that would be a what? A D, right? That's why sometimes when you get to college, some people want the professor to grade on the curve because they go by the mean. Tonight's home plate. Let me show you. Two problems. One, Mr. Q asked students for their shoe size. 7 students, there they are. And the other one, Mr. Q asked 8 students for money. And there it is. $10.25, and so on and so forth. Find the standard deviation and make sure you plot that on the curve. All right, we'll stop right there. Video lesson should be uploaded. Make sure you go to it if you need the extra support. Have a good one. Bye.